Hello?
Hello.
Hello?
Hello, engineer. I just did a brief introduction for this session. So now the floor is yours for moderating it. Thank you.
Okay. Thank you very much. I would like to introduce, but you know already, Hans with the fifth speech. Yes, really a very impressive curriculum in the area of military application and simulation field. And I believe that it will provide us with really well-detailed information, and I I provide. You have the floor. Thank you, Hans. You may start.
Thank you very much, Giovanni. I will start sharing my presentation with you. I'm hoping that you can see it right now. So today we're going to talk about innovative automated analysis tools for after-action review using artificial intelligence and modeling and simulation, and then constructive simulation in particular. But first, I would like to say that we did this development in cooperation with the French DGA, the Ministry of Research and Education, and with the Laboratory of Science and Information and Communication Technology. So let us first start to see what the position is of after-action review in, let's say, regular command post training. Here you see a typical picture, but on the left hand, you see the first level trainee giving his missions through his normal means of communication, looking at his command and control, his mission command system, and then communicating these missions to the second level trainees, who at the same time can be the operators of, in our case, Mother Sword. And then reports will be sending back about the impacts of the missions in the reverse direction, and reported to the first level, back to the report to the first level trainee. And on the right hand side, you see the after action review. And again, that's classically done with commanders to be trained. Trainees are evaluated through video, playback, audio, screenshots, verbal analysis, and so on. But today we would like to add something, to add a new approach to this. So let us quickly go into that, because we have like a couple of elements that are part of that. First of all, our own MASA group's own constructive simulation called MASA Sword. MASA Sword is giving us access to the tactical situation on a global and detailed level, and it's showing us the timeline of events and scores. So that's the basis, that's the foundation, and on top of that, for purposes of after action review, we have added a new element which is called a narrative graph. I'll explain you what it is, but it's a new element. The second element we're going to add is a synthesis vignettes. These are vignettes that will make us understand the global tactical context in a better way than a complex operational picture, a common operational picture, which gives us, in many cases, too much information. And finally, we're going to add the interactive vignettes to do what-if analysis. So why did we use MASA Sword? Well, first of all, obviously, because it's around constructive simulation, that's pretty obvious, but there's more reasons. There are more reasons. Most important, actually more important than that it's our own constructive simulation, is because it's based on artificial intelligence. And our units are equipped with realistic behavior that is consistent with military doctrine. The units have, so to say, a brain. The units are autonomous once received a mission. To give you an example, I can make something up like a platoon receives a mission to cross a bridge. Then unexpectedly, the enemy from the other side opens fire at our platoon. And traditionally, this platoon would then carry on walking because they haven't received a counter mission. But in our case, in MASA Sword's case, they have a brain and they will say, okay, we will withdraw or search for cover, or maybe even carry on our mission if the force ratio is still okay. So the Master Sword units are equipped with a brain, and once a situation changes, they will adapt their behavior. The second reason is that Master Sword is useful around the world. And the third reason, I think, is maybe the most important one for you, because when we started developing Master Sword, we realized ourselves that your job in the military is not changing like in the 90s, every 5 years or something, but it's changing at a much faster pace, like every 5 months. And that's why we wanted to build a generic constructive simulation, which will move with the challenges you are facing every day. So not only for traditional command post training or, let's say, conventional warfare, but also for tactical, for logistic command post training, decision support, operation analysis, asymmetric warfare, robotic systems, urban conflicts, disaster response, etc., etc. So that's the reason why we took Master Sword. So might you have fallen asleep? The interesting part is starting right now. I'm going to start this video already, and then hopefully it works. Yes, it works. Because this is the foundation of the vignettes, the narrative graph, and everything I'm going to show you. This is the scenario. So basically, the blue units, you see the intel units already starting to advance. They need to conquer a line and to build a stronghold on this tactical L2 line. So I'm going to fast forward a little bit, and then we'll end up somewhere here. So this is only to give an example about what we're going to work with in the next couple of slides. So first, as you remember, the first element was a narrative graph. What is a narrative graph? Basically, a narrative graph tells you one thing leads to another. We're going to put the events coming from the simulation in a causal relationship. And when I'm talking about events, I'm talking about missions, about fires, about movements, about damage, and about detection. An example of such a causality, such a causal relationship for a narrative graph could be damages caused by direct or indirect fire or mined areas. A move is the consequence of a mission, and a detection is caused by a move, etc., etc. So the goal is to provide you with support for the narration of a set of events to better evaluate the trainee. So the causal relationships are always coming from the simulation, as I already mentioned. So let's go to the next slide. This is an example of a narrative graph. You probably cannot see it on your screen, but I will quickly tell it. This unit, I don't know if you can read it, this is a unit receiving. So we're extracting a part of the entire picture, and we're focusing now on this particular intel unit, 224. It's receiving a reconnoitering mission, and then as a consequence of that, it starts to move. And during this move, it's been detected first by this red unit, and we detect in return the blue unit as well. Then it's recognized from two sides. Then there is eventually there's an identification between the blue unit and the red unit. And as a consequence of that, there is a fire exchange taking place. And again, as a consequence of that, damage is taking place, which will eventually lead to the total destruction of our unit 224. And everything is timed. So we know exactly what time it happens. It looks very simple, but it's not as simple as that to generate it. But we generate it from the low-level artificial intelligence from Master Sword. And it gives you a narration. This happened as a consequence of that mission and your execution of that, etc., etc. So that's about the narrative graph. Now we're going to the second element, the vignettes. So here you see the entire common operational picture, and here in the middle you see our unit 224. And now we're going to simplify, we're going to extract a vignette. For instance, here a vignette about local force ratio. And our unit 224 is here, and you see kind of the coronavirus here, which means that the force ratio is unfavorable. So that's one of the reasons that already indicates that something is probably going wrong with our unit 224. We're coming back to that in more detail. Here we have a vignette about battle lines. So here we have our line of attack, and here we have our the forward line of our own troops, so the most advanced units, which are in this case only the intel units. And you can see it already gives us an indication of why our Unit 224 was destroyed, because it was 8 kilometers away from the first combat unit. And here we have made a distinction between the type of missions. We'll come to that. Let's zoom in a little bit. So this is more a dynamic vignette about the sensor capabilities of all the blue units, our own units. So you see all kinds of colors. Dark blue means detection, light blue means recognition, and white means identification. And you can clearly see which part of the terrain we cover in intelligence. And you can also see the efficiency of our helicopters, of our because they are the fan-shaped images that you see moving. So this is a dynamic vignette only showing the sensor capabilities. And again, this comes from Massasourt's lower level artificial intelligence. Now back to the mission type. So here, what you see here, you see maybe, I hope you can see it on your screen, you see little light blue dots. Those are the units that have intel missions. So that's the mission type they're having. If you look at the spear points, those are our units that have offensive missions, the most advanced part of it at least. And then you see the lightning bolts. They are more the support, the engineering and support troops that are following. And for red, you see we only put the defense missions in. So these are either defensive missions from red, or they are constructions being engineered by the engineers. Pretty obvious to say that twice, sorry. So that already gives you an indication of what is happening. And let me show it in a more dynamic way here. So it's following the path of the images on the right-hand side. So this vignette makes it easy for you to analyze the moves that were made and the new positions that are taken. And again, you see the intel missions here, you see the spare points, and you see the lightning bolts following. Let's go.
Okay. You have 2 minutes.
Okay, they have to go quickly. Give me 4, please. Again, this is the local force ratio. So again, unfavorable local force ratio is the corona sign, so to say. The neutral is there's nothing in there, and the dotted is favorable force ratio. And here's the same. So let us go to the dynamic one. Here you can see it moving. So, and again, it gives you an idea when the enemy is detected and the evolution of the local maneuvers. Let's go to the battle lines now. We've seen it already. This is including our reconnaissance units, and this is our combat line of attack. Here is the same picture, but then shown in a dynamic version. And this is what we call the snail trail. It also is very interesting. It gives you an idea about the terrain covered by our units. And you can see that we had to make a lot of moves in contrast to OPFOR, who was hardly making any moves. This is showing here the static vignette about the direct fires. Circles are the origin of the fires. Stars are the blue stars are the targets, and this is the timing. And again, you see the dynamic vignettes here at the bottom. And finally, we're going to our what if vignettes. So this is also meant for decision support, so also for operational use. What would have happened is this vignette saying what would have happened if we would have supported, if we would have come to the help of this particular unit here. But we need to know the timing. So we're using Massasourt's automatic pathfinding. And here you can see the bold lines are a short arrival time, the thin lines are average, and the dotted lines are long arrival times. And it won't surprise you that our rotary wing units here can come to the support of this unit in the shortest arrival time. And here you can see the selection by that. I'll skip the next one because that's the other way around. What would have happened if we would have destroyed this red unit? And finally, this is a contextual information needs to be put in context. These are the areas. Black is reconnoitering missions, red offensive. This is to be secured, and this is already secured. But we're combining it with the presence of enemies, and if there's an enemy in one of those areas, the system is sending out an alert, and that will definitely happen when we encounter enemies in the green areas, and will definitely not happen if we find enemies in the black areas. Last slide. So this was about after action review and new tools, but we get a lot of requests in these days to use this also for decision support, course of action analysis, and also concept development and experimentation. Thank you very much.
Thank you, Hans, for your very high-speed presentation, because we were really crowded by information. And I have a quick question. This is a proof of concept and is an offline simulation tool, of course.
It's
not
some of the vignettes are already bought by our customers. For instance, one of them is the snail trail you saw, so it's working in combination with Master Sword. And others are still a proof of concept, but again, some of them are already operational and can be included in Master Sword. It's not part of the standard yet, but we're going to do that in the future. And yes, they're being used already by several of our customers.
Thank you very much.